back to your favorite pre-calculus class. Today we're going to talk about inverse trigonometric functions. So we're going to go ahead and evaluate and graph the inverse sine function, look at the domain range on that. We're going to do the same thing for the other inverse trig functions. So the arc cosine and the arc tangent and so on. So those inverse trig functions, not the reciprocal, the inverse, okay? Then we're going to evaluate some compositions, all right? So let's think about initially, let's look at, if you recall, the old sine function, right? Let's talk about if f of x is the sine of x. Actually, that f is driving me crazy. And we're like, sine of 0 is 0, sine of pi halves is 1, sine of pi, oops, sorry, sine of pi is 0, sine of 3 pi halves is negative 1, 2 pi 0. Sine of negative pi halves is negative 1. Sine of negative pi, 0. And anyway, so we draw the old sine curve, right? The old beloved sine curve. Okay. Well, if you notice on this sine function, if we're talking about an inverse, not the reciprocal. Now we know the reciprocal is the cosecant of x, right? That's the reciprocal. So now we want an inverse. An inverse. In other words, what function would it be that is going to flip-flop these? Right? So we want those x's and y's to flip-flop with our inverse function. Okay. Now to have an inverse, we have to be 1 to 1. So in other words, 1 to 1 meant that if f of a equals f of b, then a must equal b. Okay. So in other words, you have a test for that, right? And that's the horizontal line test. So if you run the horizontal line test on this, and you're like, wait a minute, I definitely hit more than once, don't I? So it fails. It fails being 1 to 1. So it does not have an inverse. So what mathematicians did is they got greedy and they said, you know what? I'm going to force this thing to have an inverse. So what I'm going to do is I'm going to restrict the domain. So they took it and they say, let's make this, let's cut everything off of the sine. So let's forget about everything else except between negative pi halves and pi halves. Okay, so everything else, we're like, let's forget about this stuff. Okay, and then now let's see, is this thing 1 to 1? Sure it is. Okay, it passes the horizontal line test. So now I can have an inverse function. And so, and let's talk about this domain again. So they've restricted this domain between negative pi halves and pi halves. Okay, and your range, of course, lowest y value, negative 1 to 1. Okay, so now it is restricted here. All right. And they said, well, let's name this inverse function. Let's call it the arc sine. The arc sine. Oops. ARC, arc sine. Oh, drive me crazy. Or the arc sine of x. Okay? So that's the inverse. That's the inverse function. Okay? That's the inverse of the sine. So now you think about that and you're like, well, what does this thing look like then? Okay. Well, we know the point 0, 0 on the original. You flip-flop that, it's still going to be 0, 0, right? That point pi halves 1 now becomes 1 pi halves. Okay, 1 pi halves. So let me have this be 1 and negative 1, and let me go up pi halves, because now you got to think about this. The old domain is our new range, and our old range is the new domain. Okay, so the domain is now between -1 and 1, okay? So we're in between here, right? In between there, between -1 and 1. And we're between, for our range, now between -pi halves and pi halves. That was the old domain, right? Remember that x's and y's flip-flop. So up here to pi halves, about what, 1.57 or so. -pi halves down here. Okay, so now we got 1 comma pi halves right there. And you notice this old point right here, pi halves -1. So that's going to be -1, -pi halves now. -1, -pi halves. We know we go through 0, 0. You know, let's get it through. This pi 0 is outside our domain over here, right? Because we're restricted now between -pi halves and pi halves, so we're not going to flip-flop that. So how about a few more of these points from the original sine? Like we had, you know, we had like pi thirds. I'm sorry, pi 6. Let's go with pi 6 here. You know, 30 degrees. You got pi 6, and the sine right there is a half. Okay, so that means flip-flopped around, or a half. Pi 6. Half pi 6. Okay. And flip-flop. Anyway, so we start, let's go -pi 6, you know, you have -1/2 and so on. And you could start graphing a whole bunch of these points. Oops, that's not very good. It's kind of got some curvature there. That's 6. And it kind of looks like that. Okay, so it's got a little curvature there, right? And if you want to think about, well, I'll leave it at that. Okay, so the new domain is from -1 to 1. Your range from -pi halves to pi halves passes the, you know, the old one passes the horizontal line test. It's 1 to 1, so that's why we can have the arc sine function. Okay, so the old sine function didn't really have an inverse, but it did if we restricted it, and that's what we call it, the arc sine. Okay, and that right there is what it looks like. So let me extend this a little bit. Let's do a few problems here. Let me erase this. Let's do some evaluations now. Okay. Let me do a formal definition first, actually, guys. Definition of the arc sine. The arc sine function. Or if you will, we'll call it. Okay. So y equals the arc sine of x if and only if, or if you want to put that arrow, that's the same thing as if and only if, the sine, oops, sine of y equals x, right? Remember those x's and y's flip-flop. And our x now is between -1 and 1, and our y is between that -pi halves and pi halves. Okay, so that's going to kind of help us to do some evaluation now. That's kind of all right, let's go with A. Let's go arc sine of -1 equals what? Okay, the arc sine of -1. So first of all, you want to say, is it in my domain? Can I take the arc sine of -1? You're like, yeah, I'm within there, right? The arc sine of x, the arc sine of -1. Hey, it's in my domain. I can do that. Just undo that there. And I like to think about it backwards when I'm doing these. So I say, well, if the arc sine of -1 is theta, I'm sorry, that means that if and only if the sine of theta equals -1, right? The sine of theta equals -1. So you say, well, where is that at? The sine of what value gives me -1. And then you can just go back to your unit circle and say, hey, unit circle, and remember I'm between negative pi halves and pi halves that I'm looking on this, right? Where is the sine of theta? Sine of what value is -1? I say, there it is, right? But I can't name it 3 pi halves. I have to name it negative pi halves, right? So negative pi halves. So let me go back here. So we know the sine of negative pi halves is -1, right? So theta, negative pi halves. Another one here. How about let's do the arc sine. The arc sine of 1/2. And by the way, that's the same notation, right? But you can write ARC instead of the notation above there in A. So the arc sine of 1/2. So, well, I got to figure it out, right? What is it? I'll call it theta. What's it equal to? Well, that means that the sine of theta equals 1/2, right? So the sine of what value equals 1/2? So I say, well, again, I'm looking between here and here, right? The sine of what angle is 1/2? Remember, sine's y value. There it is, right? Where is it? Pi 6, right? If I rotate pi 6, the sine of pi 6 is 1/2. So sine of pi 6 is 1/2, right? That means the arc sine of 1/2 is pi 6. Okay. All right, one more on these arc sines evaluation. How about the arc sine of √3? Yeah, what's that equal to? Say, well, the arc sine of √3. What is √3, by the way? Like, well, it's more than 1. It's less than 2. Square root of 4 is 2, right? Square root of 1 is 1. So I know it's between 1 and 2. And you're like, well, wait a minute. I have to be between. I can only take the arc sine of something between -1 and 1, right? Because of this restricted domain. So I can't even do this. So this is no solution. So be wary of what you're taking the arc sine on, because again, you've restricted your original sine's domain and thus its range, because the range was restricted, which means your domain is going to be restricted on the arc sine as well as your range. Okay. All right. Let's move on here. Let's take a look at other inverse trig functions. Actually, I'll do that in the next video.